name's Omar. Today we're going to be looking at lab number 1. We're going to be covering position over time. Today's materials that we're going to be using is we're going to be using a sensor connected to our computer to demonstrate how position works over time. So just to demonstrate how this sensor works initially, as we have an object, it can be any object over a sensor. Go ahead and start it. As it moves away, the line is going to show how far in the position it's moving. As we move closer, the line is going to get closer to the sensor. So this is just demonstrating position over time.
When do we see position over time in the real world? One application can be seen in the example of an elevator's movement. When the car of the elevator begins to move upwards, a positive slope would be seen on a graph. The steeper the slope, the faster the car is moving. When the car arrives at a floor and remains still, the slope would be 0 and represented by a horizontal line. Finally, when the car travels downward to the original floor, the slope on the graph would be negative, representing its downward movement.
Alright, so in today's lab, we're going to have 5 different contestants look at 5 different graphs, and amongst those 5 different graphs that we can see here, each person is going to try and replicate it using an object, trying to just show how it changes over time. My name is Omar, I'm a senior at UTEP, and my major is kinesiology.
My name is Tessa Verela. I'm majoring in forensic science. I'm class of phase 7, and this is the graph I did.
My name's Mark, I'm a senior, I'm doing biomed, and this is the graph I'm going to try to replicate.
My name is Alejandra, I'm a junior, and this is the graph I'm going to be replicating.
I'm Emanuel Sanchez, I'm a sophomore, and my major is cellular and molecular biochemistry, and this is the graph I'm going to make.
So my name is Omar. Today we're going to be looking at a position versus time graph. Today we're going to be utilizing this sensor to determine how far an object moves relative to its time. So today I'm going to try and replicate the graph that we have shown here on the blackboard, and we're going to try and replicate the graph. 1, 2, 3.
I think it's safe as long as we don't because it's already listed.
We take a picture of the graph at the end, and
In my attempt to recreate a position versus time graph, I chose to represent graph number 1, purple. In this side-by-side comparison, you are able to see my results of my recreation attempt. I was initially as close to the sensor as possible, moving away at a steady pace, seen in position number 1. I then remained at this distance for a short period. From position number 2, this still position, I moved upwards at the same pace as my original movement, position number 1. Stopping my movement, I remained still for a period once again, position number 4. Finally moving my object downward back to the original position, position number 5.
Hi, I'm Tessa, and I'm going to be doing the second graph on Blackboard, or attempting. Okay.
1, 2, 3.
Right here.
Just mess with you gotta get the feel of it. So just mess with
Getting that all the way down there. We are given the second graph we need to recreate. You start off not moving, so at a constant, then moving down closer to the sensor before we stop moving a bit, then down to the sensor again. To get that sharp V, we have to quickly go away from the sensor, then constant again before pulling away. In the attempt example, you can see that I don't move before going downward. The constant I was supposed to make was shaky since the sensor could sense movement before I went down again. I couldn't make the sharp V since I went right back up away from the sensor. Again, shaky on that constant before moving away from the sensor for the last time. In this attempt, it was done with a laptop, so the sensor had some trouble picking it up and would also pick up on the shakiness if we moved.
My name's Mark, I'm going to try to replicate this graph right here. So what we're planning on doing is starting off nice and high first, and then gradually going closer to the sensor, stop at that position, go as close as I can to the sensor.
Like that. Okay, I'll try. Higher?
Alright, okay, we figured it out, so we have to start off really high. I was given prediction 3, and for prediction 3, the idea here was to start with the object a little bit higher from the sensor to kind of give it some space so that we could gradually, at first, for the first 3.5 seconds, go a little bit slow towards the sensor, and then there's a brief pause for about a second. And then there's a fast peak towards the sensor from 4.5 seconds to 6 seconds. So just a second and a half, just going straight down towards the sensor, almost on top of the sensor, and kind of just leaving the object there on top of the sensor to give it that pause, that steady pause for the last 2 seconds. And a small little real life scenario would be if a person's walking gingerly for those first 3.5 seconds, and then they take a small pause and they take a little break, and then it's like an increase for 2 seconds, so they kind of sprint to their final destination, and then they pause there for about 3 seconds.
Hi, my name is Alejandra. I'm going to try to do this example right here. I'm going to start on the bottom, then go higher, and then go like to the bottom, and then higher again. We're trying to do triangles. Let's see.
Take a picture of it and then you want to try it to see if it looks better. Is that okay?
That looks
That looks good.
better.
I think you're getting the concept.
I chose to do prediction number 4. We can see in the original graph 2 triangles. In segment 1, the line slopes over steeply. That means the object's position is increasing quickly, so it is moving away from the starting point at a fast, constant speed. In segment 2, the line slopes downward. This shows the position decreasing, meaning the object turned around and is now moving back toward the starting point. In segment 3, the line slopes upward once more. The object changes direction again and starts moving away from the starting point, still moving quickly. Finally, in segment 4, the line slopes downward but is less steep. This tells us the object is moving back toward the start again, but this time more slowly than before. When we compare the original graph to the recreated graph, they show the same overall motion pattern: away, and back again. However, the recreated graph was made using a phone connected to a motion sensor. So this means we were using the phone as an object to move it close and away to the center to recreate these triangles. Even when they were not perfect, it shows a real experimental data. Because of this, the lines are a little less smooth, but the direction changes and relative speed still clearly match the original graph.
I'm Emanuel, and I'm going to be doing the final graph. It looks like it's going to be a little bit of everything going up, straight down, and then holding it still for a little bit just to go back up. So,
Really fast. Stay still. 2, 1, go. Fast, went up, stay still, and I jumped. I picked it up a little higher. Yes? Or should I do it? No, okay.
So I chose to do prediction number 5, and it here starts off at number 1 with a 1.5 meter distance, which it holds that for about 1.5 seconds, and then it slowly starts to climb up to 2.5 meters with number 2 on the position chart. And then we head downwards with number 3 for 3 meters downwards. And this one is a bit longer compared to the other sort of slopes. And heading on to number 4 is almost the exact same as number 2. However, same time, same distance gained. However, due to number 3, it starts off lower. Now, heading on to number 5, it's exactly the same as number 1. It stays at 1.5 meters and kind of holds that position
As you can see from my chart, I didn't do as good as the job as it was my first try. But heading on to number 6, it is the exact same as number 2. It has a small little climb up to 2.5, and it leads to number 7, which it is very similar to number 3. We can only assume that if we had more time for this one, it would continue this pattern onwards. And it does climb down to the 1.5 starting position, but we can assume if it did keep going, it would drop down to 0.5 meters. Initially, we had errors collecting data as we were unfamiliar with the motion sensor and the program we were using, so we had to take some time to learn what works best for data collection. For example, we switched from a laptop to a phone for gathering data from the sensor as the laptop was too big and it was harder to maneuver and move accurately and fast enough for the program to capture the data. We also adjusted the program to focus on a shorter time period so our data would be more visible rather than being drawn out, making the change in slope more noticeable. In conclusion, through the lab activity, we gained a better understanding of how position versus time graphs work and how to properly use the motion sensor to collect data and any variables that can affect the data.